Hello everyone and welcome to today's session. So we'll begin our today's practical session now. So I'll share my screen. So let's start with your revision of generics. So you might have seen this. This is a very simple generic class. So what we are doing here, right? So we have created this generic class and this is the generic parameter type T. And we are passing this T over here and this is just getter setter for this variable. Now if we make while instantiating this class, if we pass string over here, this my object will be a string. And if we pass integer over here, this will be my object will be an integer. So what's the limitation here? Can this be int or it has to be a wrapper type? Anyone? Don't refer the code. Try to remember what you have studied.
It should be a wrapper.
Yes, it only accepts wrapper type, so you cannot use int. So this is a key point to remember. So here we go. So here is an main class. So this is the my first gen class with like we have passed string over here, and this is the integer. So till Java, like mostly when generics was introduced in Java 5, what was the general issue that was solved? Like what was the issue in it is related to collection classes, right? So can anyone tell me what was the issue before?
Typecasting.
Yes, typecasting was the issue. But let's say before, I don't think in this ID I'll be able to write that code because nowadays it's having that check, all that type check in the ID itself. But let me try to just, even if it throws exception, let me just, it throws errors, just ignore the error and focus on the concept over here. So let's say I'm just writing like this, okay? So this is how it is to look like before having generics. Now ID won't allow it. Okay, let me see if ID allows it. So yeah, okay, ID is allowing it. So this is how it is to look. Now, if I want to add a, if I want to add, say, a number, then I want to add a string. There was no type check before. So this is how it was before having generics, right? So this is how it was. Now, while getting values from this list, what could go wrong? If you say, if you're trying to store this int into a string, you'll get an error, correct? Anyone? Right? If you try to get, okay, let me just show you. If you do this, you'll get an error probably, right? Over here only it's giving you error. Add cast to string. So this right now in this ID we have this support typecast support, but previously we didn't had. So these all things were not at compile time before Java 5, it was at runtime. So you should not get these errors, and while runtime used to face these errors. So after generics, these checks have become compile time. So this is another key feature of generics that you should know. Did you all were you aware of this feature? Like we didn't had compile time check for this casting before before Java 5.
Yes.
Okay, so this was the thing that I wanted to show you. This is how it is to look like, and now you know already like how array list looks like, right? Right now we have these type checks over here. We mentioned from start only what it will be. Now we have this. Previously we didn't had this kind of a thing. We had what I had shown you. So now you have these compile checks over here. All right, so I'll just delete this out because this is not needed now. Okay, so I'll just run this class and demonstrate it quickly, this one. So when we passed string, we were able to set string and get string. When we passed integer, we were able to set integer and get integer. So this is the basic simple class, generic class. Now let's move on to a generic method. So a generic method accepts the type parameter E, which is elements. So this E is used when you want to pass any arguments to a generic method. Okay, this is a generic method. So this is the syntax. If you want to have a generic argument, you need to write this kind of a syntax over here before the return type access modifier. In the generic syntax, then your return type, then your method name, and the generic this argument. Now, what all we can pass here? Anyone? What all we can pass here? Can we pass a user class also? Let's say in those videos you've seen this simple example, array of integer, array of string, but can you pass any user class here?
Yes.
Yeah, definitely we can. But I'll have to try it out because this is all the wrapper of primitive type. But let's say we create some people class, and if we try to pass it out, whether it will work or not, we'll try that after we finish with this. Then we'll come again and we'll do some more R&D and see what all it supports. Okay. All right. So let me just go to the main class. So here in this example, what all we have done, this is the generic method, and we have created this array list. We pass this array list. Let's run this. So it will print the array list, and when we pass the string list, it will print the string list. So it accepts all different data types, right? So this is a perfect generic method. It accepts all different data types, but we have not yet tried any custom data type. Like we've not created any own custom class and tried to pass it, right? So we need to try that also because this is all the existing classes. Okay, so now let's see unbounded wildcard. So what do you understand by unbounded wildcard? Anyone? What do you understand by unbounded wildcard?
It accepts anything.
Correct. It. Coming to the next concept here, bounded wildcard example. So I know through that video, it was not that very clearly, explained this part. I'll just explain it quickly. So what we have done over here is, this is an example of upper bound wildcard. Okay. So here is that thing, upper bound wildcard. So so this plot diagram accepts a list of any class, which is any custom class. Okay, let's say over here on, so we have a custom class that it accepts any custom class which is child of my drawing. Any custom class which is child of my drawing. Okay, then we are just iterating over this, and we are calling this draw method and printing whatever object is instantiated. Okay, all right. So let me show you my drawing. This is a simple interface with one abstract method, draw. Then we have circle and polygon. So circle is basically implements this my drawing and overriding this draw method. And here we are printing drawing circle. And similarly in polygon, we are printing drawing polygon. So these both circle and polygon are implementing this my drawing, right? So in Java, you might be knowing this concept of upcasting, like a child can be returned to a parent, but a parent cannot be returned to a child. Java does not support that downcasting. Okay, so that is what is done over here. So basically, we are writing like this: question mark extends my drawing. So you can write any child class. So this is an interface, I know, but interface also, if even if you do this, like if you use a reference of an interface, your child can be any class that implements that interface, right? If any one of you might have used factory design pattern, there we use it very often this way. Basically, we go for interfaces rather than classes because of the limitation in Java that we can extend only one class, right? So you might have implemented this factory design pattern also. So correct. Anyone has implemented factory design pattern?
Yes.
Yes, yes.
So don't you think it looks like that only over here? It a list that is that can be child of my drawing. So we are basically hiding the instantiation of the object. It is kind of a factory design pattern over here also, right? Using generics. This is the concept of factory design
Yeah.
pattern. It says hide the instantiation of object creation. Okay, so you can say this is also an kind of an example of factory design pattern. And so what we are doing is, this is clear, this is an interface. These two classes are implementing that interface and just overriding the method and writing their drawing their respective thing, like this is drawing circle, this is drawing polygon. And let's see the demo then. And this diagram plotter is also very simple. In this diagram plotter, what we have done is, this is taking an argument, a list of anything that is child of my drawing. So in our case, it can be a list of circle or a list of polygon. Then we're just simply iterating over this drawing and calling the draw method. So if it is a list of circle, which method will be called over here? Draw method of which class? Circle or polygon? Circle.
Mhm.
Correct. And if it is polygon, then
Polygon.
correct. So that
Yeah.
is what it is. It's kind of a factory design pattern. We have hidden the implementation of the object instantiation by using this generic syntax. Okay. So let's execute this. So it's demo class. And here in the demo class, you can see we have first created a list of polygons. Then we have added an empty polygon to it. Why we have added empty polygon? Because we have hard coded the implementation inside polygon, right? Here we are just hard coding this implementation. We are not passing any string to print anything specific. It just sys out like drawing polygon. Simple example. So when we call the draw method on the object of this polygons, any object will get that drawing polygon. So here we have one object of polygon. So when we iterate this polygons, what will be printed? It will print only one drawing polygon. When we iterate the circles, inside the circle list, we have how many objects of circle? Two objects. We've added two objects here, right? So can anyone tell me how many times it will print drawing circle?
Plotter is having a for loop, no?
Yes, it is having a
Yeah.
for loop. So
So
what is,
two,
how it is, I know it looks confusing. So that for loop is in this diagram plotter.
yeah, so 2 times it will print.
Correct.
Circle.
Correct. So yeah, I understand. This example looks little confusing, not too much. So it is like this, like so we have created this. So when we create this and when we add it, that time it's not printing. But basically when we are instantiating this diagram plotter and passing calling this plot diagram method and passing this list, that time it is saying. So these again, can these if I create another list of say rectangle and I am not implementing my drawing on it, so will it accept that? Let's say I create another let's say another class here, let's say square, and even if I write here, let's say similar way, I'm not overriding that method. Sorry, yeah, I'm not overriding that method here. So let's say if I do this, will this can anyone tell me like whether it will accept if I create a list of that square, will it accept in this diagram plotter?
No.
No, it will be compiled an error.
Yes. Okay. Coming to the next, bounded wildcard. So this example is clear, right? So here we had used that extent, so which was upper bounded. Now we'll see lower bounded wildcard. So this is an example of lower bounded wildcard. So why is it called lower bounded wildcard? Because it can be list of what?
Parent class,
Yes, list of parent of which class?
integer.
Correct. That is what it is. And let's see the demo. So this is very basic, like we have written a print list of parent of this integer, and we are just iterating this list and we are printing it. Okay. So let's go to demo. So here we have this simple example. Here we have instantiated our my bound wildcard with super. We have created a list. We have added these elements to the list, and we are printing this list. Simple. Let's run this class. Okay, I'll have to do it right click where. Okay, sorry, it's demo. Yeah, let's run this class. Okay, so here is it 12, 21, 90. Simple, right? Now if I create a list of string, will it accept it? If I create a list of string, will it accept it?
No.
If I create a list of long or float, will it accept it?
Yes.
Correct. Because anything that is super of integer, it will accept it. Okay. So this is clear. So that custom class we have seen over here already, right? This was an example of a custom class in this, right? So that I think is not a problem. So that is already covered, because here we had these custom classes, right? Circle and polygon, and we were passing this over here. Okay. Coming to type interface. So again, it is like your factory design pattern only, I felt like. So this is the main class. Here we have created one simple, this is very simple example. One class, named it implementing class. It implements two interface, interface one, interface two. The blank interfaces. Okay. So one question to you guys, Java question, not generic space. Are these simple interfaces also marker interfaces, or marker interfaces are empty interfaces but have some special characteristics? Anyone who knows marker interfaces in Java?
Yeah, that is used for annotation, but these are simple marker interfaces only.
Yeah, but it doesn't have any special functionality. It's just simple interfaces here. Okay, you can just study about it little bit about marker interfaces, different marker interfaces that are available. So this is a simple class implementing these two simple blank interfaces, and just instantiated this class. What will be the output of this instance of this will be obviously true, right? The first statement, line number 10, because it's the object of this, it will be true, right?
Yes.
Second statement will be,
Is it implementing interface one?
yes, implementing classes, implementing interfaces, interface one and interface two. It's implementing both the
Both the interface.
interfaces.
Okay.
Yes.
Yeah.
So this will be also true.
Yes.
Third one will also be true.
Yes.
So this is only the understanding of type interface. So the word seems little confusing, but this is what it simply means. And interface is a type in Java in simple words. For below example, we can say we can use reference of interface one and interface two. For here, instead of this implementing class, can we use interface one, like this? Can we do like this? Interface one, IT one, new implement. Can we do this? Will this work? It's working,
Yes.
right?
Yeah.
That is, so this is only the meaning of type interface. So we can have create object of implementing class with reference of any of its implementing interface. This is the practical meaning of type interface. So don't get confused with the word. Here is the meaning of it. Okay. So the difference between this is clear, like we need a type parameter to enforce type safety, which we cannot achieve with wildcard. So we have seen that. This is clear. Type interface was very simple. You already knew it, but didn't knew the word type interface. So someone had asked that out. So I've just written a simple example. Coming to wildcard capture, this is very interesting. Okay, so someone had asked understanding of wildcard capture. So the first answer I would say is the term wildcard capture refers to the fact that generic methods can work with arguments. Okay, so generic methods can work with arguments. We've already seen that, right? Now, what is the meaning of word wildcard capture? Anyone, what do you feel when you hear the word capture? Or what do you think when you hear the word capture? Can anyone tell me?
Is it argument passed?
Yeah, we can say that. So it is like I've created to explain this. Let me explain you answer number two. That answer number one, even I didn't like that. So I've written this answer number two and added the Oracle documentation link. So this helper method was little difficult to cover because it was not supporting in this ID, but I have still created a similar kind of an example that would simply show you the helper method. like kind of an helper method, not exactly the helper method. For more details, I've added this Oracle link. All right. So in some cases, the compiler infers the type of a wildcard. Okay. So in some cases, compiler, what it does is infers. What is the meaning of infer? It tries to guess, or we can say it tries to, you know, say that this is the type of the wildcard. Wildcard means unknown type, right? So it tries to infer. Okay. The compiler infers the type of wildcard in some cases, not all cases. So an example is a list may be defined as this, but when evaluating an expression, the compiler infers a particular type from the code. All right. So you have created the generic class. Okay. And let's say for this example, method example, you have written this, not this one. Let me see that question mark one. Question mark unbounded. Yeah, you have created this example question mark. So how does compiler know what it will be? It will be list of string or list of integer. How does it comes to know? And while compile time, when it checks, or while compiling this class, what it does? Okay, let's think in this way. While compiling this class, what does it put in place of this question mark? This is the type eraser now.
I think the object itself it will put.
Correct. Why object? Object is what in Java?
It's the topmost class.
Yes, parent of all classes by
Parent
default.
of all.
Correct. So that is why what compiler does is it scraps out all the generic syntax. It scraps out all that type parameter and this question mark, and it puts object over here and places that class. Now object can be, you know, casted or converted to anything, right? If you have a question mark, it can be converted to integer, can be string. There are ways that Java can do that, right? Okay. So that is the type eraser. Type eraser is nothing, just this simple concept. While compiling, what Java does is it scraps out the generics out of your class and puts object in place of that. That is what type eraser. Okay. Now wildcard capture, we'll come to wildcard capture. Now let's say we have two classes, this Gen 1 and Gen 2. And let's say in this example, like we are setting this two values. Okay, this Gen 1. Okay, it's like your pair class, but with same data type. Both, it is like pair of same data type. Okay, it is pair of what? Same data type. TT. Only one T over here. So, and these are nothing but getter setter methods for this simple v1 value 1 value 2. Okay, and this is similar class. Now let's say you want to capture values that are set to Gen 1 and set it to Gen 2. So that is nothing but wildcard capture. Okay, that is the concept of wildcard capture. And the type eraser also you have understood, right? So why is it this? So yeah, so it sometimes, yeah, here is it. In some cases, the compiler infers the type of wildcard. Okay, so here you have created this integer. Okay, you have set value 1, value 2. You have created Gen 2. Then you have created this copy Gen 1 to Gen 2. You are passing G1. So here it is not, you don't you feel it is automatically inferring that this V that we have written over here will be this, I mean, will be integer. It is inferring that, right? Compiler is inferring that. That is why you're not getting a compile time exception over here, right? You got the got the meaning of it. See, this is Gen 1. Here I've said this Gen 1 has two variables, that value 1 and value 2, and both will be integer. So it is as good as writing here integer, right? Correct? This you understood, right? This part, like, is as good as writing integer.
Yeah.
Now you set the value 1 and 2. When you're calling this method over here, it is taking that Gen 1, okay, and you've just created object of Gen 2, which is another class, not the same class. It's another class, okay, another class object. And you're setting this value. Now you have not written your integer, but still it is setting the value of integer. Still it is able to set. Correct? See, if I run this, it will work fine. So this means See, Gen2 is another class, Gen1 is another class. Gen1 I've set the value of V1 and V2 as 1 and 2. Then I'm copying the values from this Gen1. Okay, I've passed this Gen1 over here. Okay, I've just created this G1 and this Gen1, passing this Gen1 over here. Gen1 comes here. I'm getting the value of V1 setting to G2, getting the value of V2 setting to G2 V2, right? G2 is V2, and I'm returning it. So here in the G2, while instantiating the object, have I written here integer or have written here V, generic? What have I written here? Have I written here like this? No, right? I've written here V, right? If I write here integer, here also I'll have to write here integer. But have I written that? Let me show you. See, now I've written here integer. I've passed also V, right? So I'll have to make this also integer, right? It is working fine over here. Here also I'll have to write everywhere integer. It will work. Okay. Trust me on that. Now I have not written here integer. Still it is compiler is able to infer. So is this clear? What is the wildcard capture? Compiler is able to infer while setting the values of G2 that G2 will be Gen2 of integer. It can be Gen2 of integer. It is automatically inferring that. I have not told compiler that Gen2 will be a class of integer, that generic type will be integer. Have I told that over here? No, right? Is this clear? What is wildcard capture? Anyone?
So on the top, if you put string or something, it will throw error.
If I
Gen2.
put string here, then I have to place string values here. It will still work because compiler will automatically infer that. Okay, so let me show you. If I write here, let's say Sam or Vikram, and here also I am passing. Okay, here also I'll have to change to string. So it will still work. Oh. See, because compiler is automatically inferring the type of V for Gen2. Gen2 type parameter, compiler is inferring what it will be on basis of what we are trying to copy to it. Compiler is that smart. It is able to infer. Infer means to guess what it can be and automatically set that. Correct? You saw that, right now?
Yeah, it is clear.
So is everyone clear? Can everyone write clear if they are clear about it, or if still not clear in the chat?
Yes, yes. Oh.
All right. Okay. So wildcard capture concept is clear. So it's good. It was a complex topic, wildcard capture, to explain. Helper methods, I have not done exactly helper method over here, but it's kind of a helper method that I've written because my IDE was not supporting that what Oracle documentation had written. So I just wrote my own to give you the gist of it, like what it really is. So this is an example of generic method swap. So the swap is a generic method. So here I have this. I've reused this Gen1 from this class. I've set value 10 and 20 to V1 and V2. Then I'm before swapping, I'm printing the values. Then I'm just setting this like reference to another reference of unknown type, this integer to this, and then calling the swap method. And after swapping, I'm printing it. So this swap method is a helper method here. So we are able to swap this, right? And what we are passing Gen1 of unknown type to the swap method. So this means the swap method is able to accept any type over here because we have passed here question mark C. Correct? See, the generic method like below is only called helper method. This will work here. Non-generic method cannot work for the swapping use case. So if you use this non-generic method, if you use a wildcard over here, it will not work for this swapping example. So that is why this is called a helper method. Let me see how I can explain this one. This is gen 1. Okay, we are setting value 10 and value 20 to this. Then before swapping, we are printing the value. Then while swapping, before swapping, if you see this line number 28, watch this line carefully. What we are doing? Can anyone explain me what we are doing over here? Anyone? Vikram, Naveen, anyone? What are we doing over here? Guys?
The type can be of anything actually. And
Yeah,
we are
but why are we doing that? So if I directly pass G1, will it work? If I directly pass G1, will it work? It looks like it will work. So it still works. Okay. But when we make it even unknown time, that time also it works. So this is a helper method. It works for unknown type also.
okay.
See the way it is designed. This is a variable of any type that is being passed from there. So here I've passed question mark. Still, so if I try to swap long, okay, I create gen 1 of long and I pass it like this, so it will even do for long, swap long also, correct? Let's try it out. What do you say? It will work for long also, right? Or you don't want to try it out, or we just should proceed with the other method? Is it clear like what it is doing? It's not that I mean, I know it won't be that very clear because the exact use case was not supported in Java 8, but I still try to show you the gist of it. Let me just uncomment this. So this method will not work. So if you see over here, what errors it gives. So swap with generic. Okay, so here instead of we have used wildcard. Now if I'm trying to pass this question mark thing, will it work? It doesn't work. See, question mark gen 1 of unknown type, if you pass over here, it doesn't works. Gen 1 of unknown type, if you pass to this type safe, it works. I've written here object, so there is no type safety. Here there is type safety. Whatever is passed here, it will be same. But is it sure like this question mark will be object over here, like we have over here, this V and V, correct? Are you getting the point?
What is error coming?
Error, no? Let's see. Method set v1 capture 2 of question mark of unknown type in the type gen 1 capture 2 of unknown type, not applicable for arguments capture 3 of unknown type. So it says capture 3 of unknown type. Not exactly very clear about this error. So it is just like for demonstrating what it can be.
It is
So-
because in Gen 1 class, you might have defined T or something. Can you go to Gen 1 class?
Yeah. So gen 1.
Yeah, that is the reason.
What do you feel like? It is T over here then?
Yeah, that's why. And there you are putting question mark.
So yeah, it needs
Not-
that only. If we use question mark here, then it can work. Because here we are saying it will be type safe. It will be, these two will be same. But if you pass question mark, it means it can be anything. I mean, right?
Yeah, it's not defined basically
Yes.
when you are passing here.
Yes. Yes. So this is only a helper method example that you see over here. I mean, you can just try out this in more detail, this method. And we'll comment this out. So this helper method exactly, it doesn't support with Java 8 and this IDE. So I still try to explain it as much as I could by creating this example. On official documentation of Oracle, also this method is there. I mean, not this example, another example is there, but that wasn't working. So let me show you that page. So here I've added the link. You can try out this link, but the example on that documentation will not work in the local. So you might think, okay, I understood by looking at that example and after 10 times after reading that documentation, but still you won't be very clear. But if you go through this example that I've created 5 to 6 times maybe, then you will become more clear. At least it will be sure that you become clear. and some of you have still become very clear. So should I proceed with the next concept of type eraser? Guys?
Yes.
Okay. So this helper method, you can just do more R&D. It is not that great or important concept, but yeah, it's a tricky concept, very, very tricky concept. Okay. So here what we have done is, yeah. So here what we have done is we have this, we have this gen class which has two different this type parameters. This can be one type, this can be another type, right? So this t can be string, this can be integer. See, this is how you'll instantiate it, right? Integer string, and you'll then set the value as 50 and 50, integer 50 and string 50. Then this is the next one. Float double gen 2, which can be like float double 50f and 50d. So what internally Java will do when you write this, will it create two classes internally for gen, like one like integer and the another one like this string. Okay, one class will look like this, another class will look like float and below double. So will it do that? Will this be the case? Or what, how Java will compile and keep this class? Will there be two classes if I have two objects, or will there be only one class?
If T
Only
and
one
V
class.
both will be removed by object, then one class will suffice.
Yes, so both will be replaced by object. So that is what Java does. While compiling it, it scraps out all the generic information that you have added, it replaces it with object. So if you see over here, it is only creating one class out of it, correct? One compiled class. And this will be replaced by object. So can we check that out? Dot class file we'll have to see, right? Okay. So coming to the next one, how internally Java compiler compiles it and makes it. So you are already clear about it. So I've just written an implementation over here for the above method. It will look like this: object, object, constructor to set that value, object, object. So all that T and V will be replaced by object. This is how it will look like internally. So is this clear how internally it will work?
Yes.
So this is nothing but type eraser. So here I've written the explanation. The implementation of generics utilizes the type eraser. So what it does, it erases all these generic types and replaces it with object. This is very simple definition of it, the way you should understand. Then in general, here is how the type eraser works. When your Java code is compiled, all generic type information is removed, or we can say erased. This means replacing type parameters with their bound type, which is object if no explicit bound is specified. Yeah, so here have we specified any bound? What do you mean by specifying bound? Like if you write question mark extends number, question mark extends people, or question mark super people, or T super people, that means it has some bounds, right? Correct?
Yes.
Yes.
So here it says this means that replacing the type parameters with their bound type, which is of object if no explicit bound is specified. If the bound is specified, then it will not replace like this. Then it doesn't uses the concept of type eraser. It uses something else. Okay. But now we know at least what is type eraser and when Java uses that. It uses that when you have not specified any bound. So here we have not specified any bound. This T and V can be anything. And whatever this T is, this T1 will be that. Whatever this V is, this V2 will be of that type. Okay. So so which is object? Okay, let's read this again. This means replacing the type parameters with their bound type, which is object if no explicit bound is specified, and then applying the appropriate cast as determined by the type arguments to maintain type compatibility with the type specified by type arguments. The compiler also enforces this type compatibility. This approach to generics means that no type parameter exists at runtime. Yeah, so at compile time only it creates this object, this internal class, correct, while compiling the class. So this doesn't happen at runtime. The compiler enforces this type compatibility at compile time. This approach to generic means there is no type parameter exist at runtime. So while runtime, there is no this T and V inside. So there is only this object inside. That is what it means. Okay. This approach to generic means that there is no type parameter. These are type parameters. T and V, these are nothing but type parameter. Correct. So while runtime, there are no type parameters exist at runtime. So the gen integer string and this gen float double are versions of gen type for each formal parameterized type. So both of these are nothing but we can say same version of this one type internally at runtime. Correct? Is this clear what it means? Internally, basically, by looping it, they are simply saying they are just scrapping out the information of this type parameter, creating class like this, and it is only possible to create class like this when there is no bound. There is no bound, there is no extends or super keyword. So there is no bound. This can be anything, this can be anything. There is no bound on it. Upper bound, lower bound, no bound. Correct? And that is the concept of type eraser. Okay, thank you guys. Thank you for attending this session. I hope you have learned the most out of this session and you will be able to do a lot with what you have learned in generics. So thank you for attending this session and see you next time.